Yes, I have answered all the questions in this interview. Hey folks, my name is Ravish and welcome back to another video in the series of DevOps real-time interviews. Now, we have a profile with us today. So this person was having around 8 years or 9 years of experience in his domain, but the thing was this person has recently moved to DevOps. So I have taken this person as a fresher, the fresher interview, because he has around 5 to 6 months of experience in DevOps. So let's talk about the profile. So we have concentrated only on AWS. So we have started with EC2. We have talked about ECS, AWS Lambda, Docker, EKS, a little bit of Kubernetes as well, EBS, a bit on Git, post that Grafana for monitoring, use case, what exactly is plugins, EFS, and elastic load balancing. So everything is going around AWS only. All right. So you can consider this as a AWS fresher interview. All right. So that would be about it. And please do subscribe the channel if you're new over here, because that really supports me to create more content like this. So without further ado, let's get started. And you started as a database admin, right? You were a database administrator for a quite long time.
Yes, sir.
Okay. How much of experience do you have in DevOps?
Like I said, I started last year, September 18th, officially.
So can you give
But
me
what
like
I've been
in terms of months or years?
in terms of what?
Months or years, like
Months.
1 year.
Okay. This should be this is my 5th month.
Fifth month in DevOps.
Yes.
Okay. And how much in cloud?
Cloud. That should be the same thing. Aside from the training I had from Good Cloud.
Okay. So did you certify, got any certification or something?
No, not yet.
Okay.
Except for the
Cool.
certificates of completion from Good Cloud.
Okay. So yeah, I can see your profile. You have worked on AWS as a cloud, right?
Yes.
Cool. Okay, then we'll start from the very basics. So there could be multiple services that you have worked on EC2, AWS, and I can see on profile all these things. So I'm going to direct my question on those services which you have written in your profile. Okay.
Okay.
So let's pick the first service. That would be your EC2. Can you describe me the different types of instances available in EC2 and their use cases? Why do we use them?
Okay, EC2 is just it's like a virtual machine that we use to host our applications. We have different kind of windows. From we have operating system. We have Windows. Then we also have Linux. Under Linux we have Ubuntu. Then we have Amazon 2 and Amazon 22. Basically, then also on EC2 instance we can deploy a lot of application and servers on it. Currently, I use it for I use it for Jenkins, Prometheus, and several other applications that we have on it. Then also, I would say EC2 is one of the main tool or module in AWS, because there's nothing you want to do that you won't go through EC2. So it's like an infrastructure you use to host every other stuff you want to do on AWS.
Okay, my question is like, what are the instances types? I mean, you explained EC2 very well. I'm asking about the instances type. We have types of instances in AWS, right? What are those?
Yes. Yeah, we have EC2 Micro, we have T2, then we have T2 Micro, T2 Medium, then Large. We also have some other ones I cannot really remember.
Okay, see, what are you telling is like more like a nomenclature kind of a thing. We have defined in them in from, let's say, 1,000 feet view. So we have general purpose, we have compute optimized, we have memory optimized, we have storage optimized. Okay.
Yes.
So can you explain me like what exactly we have in general purpose? What do we have in compute, memory, storage? Can you explain me that?
Under storage, we have S3 buckets. Then
No.
then the Okay. I don't
Storage
get.
S3 bucket is different. I'm talking about the
Yes.
type of instances in EC2.
Okay. Uh, okay. I can't really
Okay,
figure it out now.
I'll
So,
help you out. Okay, so when we talk about the general purpose, they are mostly suitable for web servers, database, and small to medium application like T3, M5 example. The other ones are compute optimized. They are ideal for compute intensive workload like scientific computing or batch processing like R5, C5. Then we have memory
okay.
optimized. They are designed for application requiring large amount of RAM. Okay, like in memory databases and analytics, P3 kind of a thing. Okay. Then we have storage
So,
optimized, and this storage optimized means optimized for high performance block storage access, basically
that's
suitable for databases and CDNs, content delivery networks. Okay, that's
okay.
pretty
Oh,
much
I
about it.
understand. Oh,
Okay.
okay. Great.
Um, so how do this is my second question. So how do you implement auto scaling for your EC2 instances based on resource utilization?
Uh, Auto scaling on my EC2. That would be I would rather use probably if I want to do auto scaling, I would rather use EKS because of the auto scaling.
Just a moment.
Okay.
I'm not talking about EKS.
Yes.
I'm just talking about how do you implement auto scaling for your EC2 instances.
Okay.
Have you ever done auto scaling?
I have not done it.
Have you have any idea of what auto scaling is actually?
Yeah, auto scaling means when you deploy your application and the more traffic the application gets, your application should be able to scale up automatically, not manually. Then, if the traffic goes down, it scales down automatically, so that you don't have to pay for redundant resources.
Okay, so exactly. So when this auto scaling happens and it has to happen automatically, there has to be
Yes.
something, right? On the basis of that, it has to auto scale. So what exactly is this? Okay, I'll help you out.
Yeah,
It's
that's
called metrics.
okay.
Any idea about this?
Yes, I think I did it on the project. I did on my own. About There was an application I deployed on my EC2. Yes, I've done it once. Yeah, metrics. Yeah, yes, once.
Okay. See, when you have ASGs, auto scaling group with CloudWatch metrics,
Mm,
like so you can use CPU utilization as your trigger. You can even define your
okay.
scaling policies to automatically add or remove instances based on resource demand. Load balancer
Okay.
to you can also use load balancer to distribute traffic across instances as the AHGs. So
Mm.
these are the things. Okay, no problem. Okay. So, what are the advantages and disadvantages that you feel we have for spot instances? Do you know what is spot instance?
Sport instance.
Yes.
No.
Okay. 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 So basically, spot instance has a few advantages and disadvantages. It is significantly lower cost than the on-demand instances. It's used for your batch processing, non-critical workloads. Okay. Um,
Okay.
on the disadvantage side, interruptions can occur because if spot price exceeds your bid, so you can take a look at that. Okay.
Okay.
Okay. Okay. Let's see what else. You have worked on. Let me go through your resume once more. Just a moment. Okay. You have worked on ECS as well, right?
Yes.
Okay. Um what is ECS and how does it differ from any other traditional virtualization?
It's AWS Elastic and Container Services.
Mm-hmm.
It used to package microservices. If you don't want to use AK Kubernetes, you use Elastic Kubernetes Container Services, which is actually for microservices and containers. So it's different from the normal. It's basically for microservices applications, unlike the EC2. So that's the difference between them.
Okay, when we say ECS, it means Elastic Container Service. Okay, what exactly
Yes.
is this container? What are you containing?
Uh, we are trying to containerize the application, in such a way. The containerized of application means that you are trying to, how would I put it? Uh, um, Package your application in such a way it can run in any environment. So ECS is one of the best tools you can use to achieve that. When you containerize your application, you can actually move it from one environment to another, or any other. It can easily run on any other platform without any differences in the dependency or anything. You package it's used to package application in such a way you have everything as a complete package without difference in, like I said before, in dependency. So it's easier for you to manage it, to scale it up, or scale it down. So that's easiest as well.
Okay, okay, okay. But we used to have virtual machines, right? Why do I need ACS?
Uh, like I said, ECS, like a virtual machine, you have to deploy the underlying OS yourself. But on ECS, the AWS it's manage the underlying application itself. All you have to do, concern yourself, is with the application running on it. You manage your application and make sure your application runs fine. So that's why it's different from a virtual machine.
Okay,
Then the application on ECS boot up and run faster than compared to the one on the virtual machine.
okay, okay. So can you explain me the key components of ECS?
Yes. We have under ECS, the components of ECS, we have uh, the runtime that we're going to use to do ECS work with Docker. So that's one of the components. Then also, um, when you say components, you mean everything that comprise of ECS, right?
Yeah, everything that we have a lot of components inside ECS, right? So anything on that? Okay, I'll help you out. What exactly do you mean by a cluster in ECS?
Cluster is where we have the like it's where house the our application. That's where we have our cluster. Is a combination of a group of pods
let's
forms.
let's not let's not go in the Kubernetes side. Just concentrate on the
Okay,
ECS container side.
okay,
Let's not talk about EKS. So cluster is basically a
okay,
logical grouping of your EC2 instances or the Fargate.
yes,
Okay.
okay.
What do you mean by task definition?
Task definition. That's where you define all the tasks that are supposed to be running on your or inside your container.
Like example?
Where you define how would I put it?
Sorry.
I'm trying to see how we put it in. Under the task, we have
See, task
I think I
definition
forgot.
is basically a blueprint. Okay, for containers, you
Okay,
specify your parameters like image, CPU, memory,
yes,
etc. over there. Okay.
okay,
Um, okay. There are tasks, there are services, there are container instances as well. I mean, as a part of components. Okay. So how does this service discovery work in ECS?
discovery.
Service discovery.
Service discovery,
Yeah.
that we can do that. We can expose a service discovery to um, the we can use load balancing. Then we can also use Notepad. Then we have load balancing, Notepad. Then there's this third other one. Um, sorry. We have this other one. If you don't want to expose this outside, load balancing, Notepad. I forgot now. Sorry.
Okay, I'll help you. So Amazon ECS will support other service discovery through Amazon Route 53. Okay. So what ECS will do, it will integrate with Route 53 to automatically create DNS record for the ECS services. This will
Yes.
allow services within the cluster to discover each other using DNS names. Okay, that's pretty much about it. Okay. I can see that you have worked on Amazon Lambda as well, right?
Yes.
Okay. So explain me what exactly is Amazon Lambda, and how does it differ from server-based architecture?
Amazon Lambda function is basically it's a code-based. I'll say it's a code-based application whereby you just package your application, then the Amazon Lambda take care of everything. Then this you are only being charged for the process, the function runs. You are not being charged for the resources. Like you package, you define on Lambda, you define the kind of language that you want to use and your application how you want it to run. So once you put it on Amazon Lambda function, then it's handle the rest of the processes. So all you have to worry about is make sure you define what you want exactly for your code. Then Amazon Lambda function handles the rest.
Okay, yeah, pretty much about it. So Lambda basically automatically scales their charges based on the execution times, and it will eliminate the need for server management. So yeah, that's pretty much about it. Okay. Can you explain me the concept of event source in AWS Lambda?
Event source in AWS Lambda. What I understand by event source in AWS Lambda is that when you are being charged when event is happening on your application, but if your application is not receiving, like let's say you are running an application that receives traffic or from clients or from the user. So when your application is not receiving any traffic from the user, that means no event is happening on your application, so you are not being charged. So AWS Lambda has a way of handling this. So when your application is not receiving traffic, it shuts it down. But the moment it's called average traffic is coming in, then it picks it up and scale it up according to the traffic it's receiving.
Okay, okay. I'll just rephrase it, a bit of paraphrasing as well. So, an event source in AWS Lambda is basically a service or a resource that triggers the execution of the Lambda function. Okay. Let's say, for an example, you can include changes to an S3 bucket. You can update a DynamoDB table or events to SNS, notification service. Uh, your Lambda functions can be configured to respond to events from various AWS services, allowing for the event-driven and serverless application architectures. That's pretty much about it. Okay. What is the maximum execution time for a single invocation for a Lambda function? Okay, it's 15 minutes basically, 900 seconds. If a function runs longer than that, it will be terminated. Okay. Okay. You have worked on Docker as well, right?
Yes.
Okay, so why was Docker introduced and what was the purpose? What was the problem that was underlying and Docker came and resolved?
When application, the developers used to develop the application, so there's always issues between the developers and the operation people when they finish their application run into their local system. by the time you are going to deploy it in a production environment, there's going to be different, a lot of issue arises. So then the developer believes that they've done their work, or the operation believes that it's not working on my environment. So when Docker came in, Docker packaged the application in such a way with all the dependency that will make it run in every environment. So Docker is used to package the application. Once you build your application image through Docker, you can actually take it to any environment and it will run seamlessly. And then these images can also be stored on Docker registry for future use or for other uses. So Docker actually resolved that issue.
Okay. 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 So can you explain me the difference between an image and a container in Docker?
Can I explain the difference between image and container?
Yeah. So difference between an image and a container in Docker.
And container in Docker. Yeah. The image is actually is what we use to build a container. A container actually needs an image to work, function, because it's like the key component of a container. Before you can build any build any container, you need image for the container to run on. So that's the difference.
Okay. Okay. I'll just paraphrase it. So your image would be a lightweight, standalone, and executable package. It includes everything: your application code, runtime, libraries, and dependencies. Okay. When I talk about a container, on the other hand, it's an instance of that Docker image that runs as a process on the host machine. So multiple containers can run from the same image. Each will be isolated from the others. Okay. Okay. So let's say you have multiple containers. Okay. Let's talk about a scenario. You have multiple containers and you want to share data between the containers in Docker. How would you do that?
Okay, we can use I can use data. That means I can use MongoDB for that.
How would that
Okay,
work?
I understand. Okay, sharing data between the containers. Okay, I can use what's this called? Network. Sharing data between containers. Sharing data between containers. Sharing data between containers.
Did you get the question? I mean, did you understand the question?
If I get it correctly, you said we have a series of containers. Then between these containers, we want to share data between them. How do we accomplish that, right?
Yeah.
Right. I forgot. I got
No problem. So there are multiple ways to do that. Either you can do it through volumes, second through bind mounts, and third from shared network. When we talk about the volumes part, shared directories that can be mounted on multiple containers. So you can do that. There is something known as bind mounts. You can do that for linking a specific file or a directory from the host machine into the container. Okay. And then we have shared network. Containers on the same network can communicate with each other. That's how they do it. Okay. That's pretty much. Let's talk about Kubernetes. So my questions would be more on EKS side, and if you want to explain it from the Kubernetes standpoint, that's also fine. Okay, EKS, Kubernetes, exactly same thing. Okay. All right. Okay. So what is this Amazon EKS, and how does it simplify Kubernetes cluster management?
Amazon EKS is basically manage Kubernetes cluster on Amazon. Then the way Amazon handles that, the Amazon actually EKS actually handles most of the underground work on Kubernetes, like setting it up yourself. When you are running Kubernetes on bare metal, all you do is to manage the surface, deploying your application on it and make sure everything, define what you want and make sure it runs fine. But EKS handle the underlying processes for you.
Okay, okay. How do you think Amazon EKS handle node scaling?
Uh, the way Amazon EKS handle node scaling is, you have to configure it when you are setting up your Kubernetes cluster. You you define it in your, how would I put it, in your declarative file, which is YAML file, how you want the EKS to undo your nodes.
Node
So
scaling.
that way, yes,
Okay,
we
okay.
yes.
See, EKS will automatically adjust the number of worker nodes in a cluster based on the demand for the resources. You've heard about ASGs, right? At autoscaling groups. They are used to manage the underlying EC2 instances and they'll ensure the desired capacity is maintained or not. So this is how Amazon EKS handle node scaling. Okay. Just explain me the concept of pod in Kubernetes and how it relates to EKS.
Okay. Pod is the smallest unit uh, of a Kubernetes.
Mm-hmm.
Then, yeah, then a cluster can have as many as possible pods running in it. Then
Mm-hmm.
pod and Zoot is like, I would say, a mini package on its own. So if one goes down, the cluster can actually spin up another one. So it is the, how would I put it? It's actually the main process inside on EK on Kubernetes.
Okay. 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 Um, can you explain me the different deployment strategies available in Kubernetes and their applications?
Different. What? Can you
Deployment
come again, please?
strategies available in Kubernetes and their applications.
Oh, okay. We have, how would I put this one?
Or if you even know how do we deploy a lot. Have you done any project on Kubernetes?
Yes.
Okay, so how do you used to deploy?
Okay. You can deploy your application. We have what we call that is common for any application that receive when you, canary deployment. Then
Okay.
we also have blue green
Okay.
deployment.
How do you
Yeah,
do that?
uh, the way you do blue green is that you when you are deploying blue green, you take it by percentage. The new the latest and the current application, you deploy it batch by batch, whereby let's say, depends on the percentage you want to define. You can say 20 60, which means you have the old package like 60% stay up and running while you introduce the new package 40%. So as the new one is coming up, the old pod is going down gradually until we have the new one deployed fully. Then the blue green deployment is whereby you the when the blue you the part of it goes up, the former the old package will be available while the old one is coming up. So when that one goes down, then the new application picks up running. As the old pod is going down, then the new one is coming up.
Okay, okay. How do you monitor the health and performance of your applications running in EKS cluster?
We can monitor that through other. We have some tools to monitor that.
Like?
We have Prometheus and Grafana. That's what we use in my office
Okay, okay.
to monitor it. Yes. That's what we use basically, Prometheus and Grafana, whereby you define the application you wanted to monitor on Prometheus, then you pull the interface on the Grafana to see the health status of the clusters.
Okay, yeah. I mean, Prometheus and Grafana are good tools. But in case you don't want to use that, you can use CloudWatch as well. You can use Kubernetes built-in metrics and liveness, readiness probes to track the container
Okay.
health. You can do that as well. Okay,
Okay.
okay. Yeah, that's pretty much about it. You have worked on EBS as well, right? Elastic Block Storage.
Yes, sir? You're breaking.
EBS.
Hello?
EBS.
Okay, elastic block storage.
Yeah.
Okay.
So can you describe me the different volume types available for EBS and with their use cases?
Yeah, we have file storage, then we also have uh, block storage, which is binary large or objects. Um, the we have series of it.
See, whenever we ask from different types of it, okay, they are always from top view. So we have general purpose, we have IOPS SSD provisioned, we have magnetic,
Okay.
and we have cold line HDD. Okay.
Yeah.
So when we talk about general purpose, they are high performance storage for frequently accessed data like databases and web services. We have provisioned, which guaranteed IOPS input output. Okay. For application requiring consistent performance like financial transactions. Okay. For example, ATMs and banks and stuff for that. We have magnetic, which is cost effective option for infrequently accessed data for or backups that you have. And then we have cold line, ultra low cost. But I think these are generally for used for slow retrieve because it's kind of slow and it's used for data which is rarely accessed. Okay, so let's say if you're using EBS in your project, how would you ensure the high availability of your data stored in the EBS volumes?
Okay, I'm using EBS in a project.
In your
Then
any project, how would you ensure the high availability of your data stored?
yeah, it depends. It actually depends on the type of storage I'm going to choose. Then
Okay.
that will also come from the kind of like you said, for the general purpose that you said, or high performance using for ATM.
You can talk
So
about
I
the
will.
general thing like there are features in EBS when you go through that. It has a lot of features through which you can provide the high availability. You can just talk about that from top view. I mean,
Okay.
any idea?
I've actually not no
Okay,
idea. I've not
okay.
done that. But
You
yes,
can,
officially, yeah.
I'll help you out. You can utilize EBS snapshots to create point in time backups. Very useful for disaster recovery. You can even leverage EBS multi AZ deployment to mirror volumes across various availability zones for automatic failover. And then you can implement RAID configuration, RAID, with EC2 instances for additional data redundancy. I mean, these are required for large project, but it's just an overview part. Okay. Have you ever used EBS encryption in any time, whether it's for project or POC or anything? EBS encryption.
No, not at all. Not
Okay.
at
Do you know
all.
how EBS encryption works?
I read about it. I'm not gonna lie. I read about it, but I've not. I can't really remember. That was when I was learning AWS. I know I read about it. There's something like encryption, where they encrypt it, then you have to use a generate a key or something like that. Before the data from it will be decrypted and will be accessed by the application. If I'm right.
Okay, okay, okay. No problem. So you worked on EFS as well, right? Elastic File System.
No, I've not worked on that.
Okay, but you wrote in your resume, no, profile. Do you know what exactly is EFS?
Elastic file system.
Yeah, I mean, like if you're not comfortable on it, I'll move on to some other question.
No, I'm not comfortable. I have not worked on it.
Okay, no problem. You have written elastic load balancing as well, right? In the profile.
Yes, yes,
Have you worked on it?
yes.
Okay. So, what exactly is ELB in AWS?
Is elastic load balancing that we use to distribute traffic from your to expose your application to the external use. So the way elastic load balancing works is that it handles no matter the amount of traffic you are expecting from user from clients to your application. So when it comes in, elastic the load balancer handle it and distribute the request to the available pod or instance that are running on your application. That's the way it works.
Okay, okay, okay. Can you explain different types of elastic load balancers?
Yes, I know. I know. I can remember we have levels of elastic load balancing.
I'll help you out. We have application load balancer, right? Network load balancer, classic load
Yes,
balancer. Do you know what exactly it
yes,
is?
yes. Yeah, the application load balancing is the word we use to communicate between the applications. It's like an internal load balancing between the application, if I'm correct.
Mm-hmm.
Then yes, then the network load balancing also can be used between uh, several instances inside on AWS. Then the classic load balancing mostly is used for the external networking, receiving, handling traffic from outside client or user who wants to access the your application on AWS.
Okay, okay. Do you know what is OSI model? Uh, have you heard about it? In which we have
Oh,
multiple layers: the application layer,
oh,
transport layer, data
yeah.
layer. Heard about it? OSI model.
I've read about it, but I've not really
Okay,
practiced
yeah.
it.
So this application load balancer works on which layer?
Um, that should be first layer, if I'm correct.
How many layers do we have?
I think you have. I think you have up to six.
I think we have 7, but
Yeah,
just check.
7. Yes, yeah, 7. Yeah, 7. Yes, you're
Which is the
correct.
7th
You're
layer?
correct. Yeah. Uh, oh, I can't remember. I can't
Okay,
remember.
it's
I don't
it's
want
the
to lie.
application layer. Your
I always-
application load balancer operates on application layer, and it's best suited for HTTP, HTTPS traffic. It can support
Okay.
content-based routing and is ideal for microservices architecture. Okay, when we talk about
Yeah.
network load balancer, it operates on transport layer, which is layer 4. Okay, so
Mm.
presentation comes first, and then the fourth one,
Okay.
and then we have multiple layers, right? It's suitable for both
Okay.
TCP and UDP traffic, high performance, low latency, and handles more complex routing scenarios. Not sure about
Okay.
classic load balancer because I'm not even sure whether it is used or not, but it operates at both transport and application layer. Okay, it's kind of legacy, I
Okay.
guess.
Okay.
Okay, how do you think elastic load balancing handle health checks?
elastic load balancing and the health check. That will be based on the response from the health check of the application, right? For the
Yes,
application.
yes.
Yeah, that will be the rest. It will be based on the response it's getting from the application, like when it's distributing. Because when load balancing is distributing requests to a pod, if the pod is not up and running or it's not healthy, then it's going to distribute it to the next available and healthy pod. So that way, it's identify. Yeah, load balancer needs to identify the status health of each pod before it can actually distribute it to it. That's what I understand by that.
Okay, okay. So you have worked on Git as well, right?
Work on what?
Git, 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 source control management.
Git. Yes, 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 yes. Git.
Okay. What do you understand by Git, and how does it differ from other version control systems?
Git is the versioning system. Like it is used to monitor the versioning of your application, whereby when the developers are done with the latest code on their local system, they push it to Git. Then Git tag it and handle it. Then if you configure your Git in such a way you have a webhook, that's when it triggers, the webhook triggers your CI/CD pipeline, which is some people use but mostly what I use is Jenkins. That's what I'm familiar with. So that way, it's actually run the pipeline to update the application and make sure the latest code is available for production or development. Depends on how you configure your. So that's what I understand by Git. It's a version tool.
Okay. Git is distributed or centralized?
Is that?
Git is distributed or centralized?
It's distributed.
Difference between distributed and centralized?
When you distribute is when you can actually send, like I said, when it's distribute, that means it can actually give a instruction to your CI/CD pipeline to that, okay, that's latest code. Then it picks it up from there. Then the CI/CD pipeline package run the new pipeline, then distribute it to the for user to have access it in production. Then when it's centralized, it's handle you have to give instruction, like it's kind of a manual before you can actually go further.
Okay. Okay. What is the difference between Git commit and Git push?
Git push, Git commit is that when you make changes on your file on Git, the moment you commit it, that means you like saving, you are committing the new changes, that the amendment you make on your projects. So the moment you commit it, if you, like I said, if you have your webhook set up, then that means it's going to trigger the CI/CD to actually run the
On
new
committing, just
image.
committing.
Yes. Yeah, commit is basically it's like save. When you save something, the new amendment or new alteration on your or code or your application. Then push is when you push the new the updates that you already commit on your application, when you push it to your CI/CD
See,
tools.
when we talk about Git commit, it records the changes made to the local repository. Okay, it creates a snapshot of the changes. When we talk about Git push, it sends committed changes to the remote repository, and that makes it available for the others. Pushing updates the remote repository with local changes. Okay, so commit is only for your local computer, your local PC, the machine. Push changes it to
Okay.
the main repository so that others can see it and take it. Okay.
Mm.
What do you understand by branching strategies?
Branching strategies is what I understand by branching strategies is that when a developer is developing the code, they have their own branch. So when they are done, they branch out, they push it to, depends on the setup, they push it to, they start from development, then they can push it to future branch. So from future branch as a DevOps, you pick it up before you actually, that's where you push it. You can branch out also to development branch. Before from there it can go to the before it can go to production. So it's way branching is a way of handling the updates and make sure the code base is not affected when you are building the pipeline. That's what I understand by branching.
Okay, basically, I'll just rephrase it. Branching strategies is something when you do a development in some project. Okay, you decide branches accordingly. For example, if you have a dev branch or a trunk branch, it is something that keeps on getting developed. It's like a river that keeps on flowing. Okay,
Mm.
and then you just
Mm.
put your code inside it. Then you have other environments like staging, production, QA, like that. Okay, so you
Yes.
take that branches and execute the CI/CD so that the relevant code goes to those type of environments. And once it
All
goes
right.
to those environments, it can be tested by further people. And we have a master branch or a release branch or a production branch. A naming convention can vary, but that's the purpose of it, that it goes to the production. So you do changes in dev, then stage, then QA, and sorry, then QA, then stage, and then to production. So that's basically a
Production.
1,000 feet view what branching strategies are. Okay. So you were talking about Grafana, right? So what exactly did you do with Grafana in the project that you created?
I what we use Grafana, we use it officially. Uh, I actually deploy it as a container on AWS when I use it for a personal project when I was testing it. So then I also use it to monitor the out of the application and the Kubernetes cluster. Grafana is actually I would say a dashboard that adds a very beautiful and more presentable information about your application. Because Prometheus actually have its own, but it's not as good as Grafana. So Grafana is a basically for I would say dashboard for uh, dashboard monitoring system. So it works hand in hand with Prometheus. So it's just like interpreting whatever it gets from Prometheus and make sure it comes out in a very good format for you to understand and monitor your applications.
Okay. Can you explain me the concept of plugins in Grafana?
The content of plugins in Grafana is that you have to impute the how would I put it, the ID for each and every application have their own Grafana uh, port ID. So this is where you actually define it. When you are doing the plugin, there are a lot of plugins on Grafana actually. So this is where once you put in the ID of each any application you want to do, that's where as in the plugin setup, that's what Grafana use to display your the health of your information about your application on the dashboard.
Okay. So how does this Grafana support data querying and visualization?
It's supporting in such a way that it gives you in a chart format for you to know the usage of each component of your application. It gives you that so you can easily collect data or have data about your application.
See, when we talk about data querying and visualization, it supports querying through various data sources, and this includes your Prometheus, okay, which you talked about, InfluxDB, Graphite. You can have even MS SQL database as well. Okay, and more.
Okay.
So users can create queries to retrieve and aggregate the data. And then Grafana visualization, we have plugins for that as well, like pie chart or something. They'll allow the creation of interactive and customizable dashboard with like charts, graphs, and other visual elements. Okay.
Oh, okay.
Yeah, I think I'm done.